In this example, we will find a polar form of the complex number z is equal to 3 plus 3i. In order to find the polar form of this complex number, we really need to calculate two things. We need to find both the modulus, which we'll represent as either modulus of z or r, as well as the argument for the complex number. To find the modulus of z, we're going to be working with the Pythagorean theorem here, thinking about the real and the imaginary components, very similar to x and y. It means we'll have the square root here of 3 squared plus 3 squared, otherwise known as the square root of 18, which is as far as I can really take it. If you would like to simplify this to, say, 3 square root of 2, that is also fine. For my purpose, though, I will keep r to be equal to the square root of 18. Then we also need to find the value of theta, the argument for z. In order to find the argument, we are going to apply arctangent to this for our imaginary and our real. However, before I move any further, I'm going to consider where my complex number should be in the complex plane, or the Gauss plane, to make sure that the angle measure I get from arctangent will be correct, and if not, adjust as necessary. Since I have a positive real of 3, that means we're going to the right here along the x-axis. And then since I have a positive 3 as well for the imaginary, we're going up on the imaginary axis. So we're looking at a complex number in quadrant 1. Thankfully, arctangent is defined to be an angle measure between negative pi over 2 and pi over 2. So this will give me an angle measure in quadrant 1 between 0 and pi over 2. So I do not need to adjust anything. However, I should be able to calculate this. If I simplify 3 over 3 to just the fraction or the value of 1, then that means that I'm looking for a value or an angle measure for tangent such that sine and cosine are equal to each other. Because arctangent of 1 really means tangent of theta, or sine over cosine of theta is equal to 1. So they're equal to each other. We should know that angle measure in quadrant 1, that angle measure happens to be pi over 4. That would be my argument. With these, I can write the polar form of this complex number, z. I can write that in two different ways. It depends on what you would like to do. The expanded form of this would be the square root of 18 times cosine of pi over 4 plus I times sine of pi over 4. That'd be the expanded form, but you can also write this with the contracted form using CIS as the square root of 18. CIS, which is cosine plus I sine of pi over 4. Either one of these would be my solution.